So, still on operations on algebraic expressions, we are doing multiplication and division for this very lecture. So, multiplication, and division. After this one, I will show you how to remove brackets. Okay, let's start. Okay, so with multiplication, it's easier to basically group numbers with similar letters together, and then you apply the laws of indices, all right, in solving. Okay, the laws of indices, what are these? So watch closely. Laws of indices. Well, indices is coming from the word index. Another word we can use to paraphrase index is what? Power, or better still, exponent. So let's take a look at this very one. So 5 exponent 2, all right? So 5 is called the base, all right? So 5 is what? The base. And then 2 is what? The power, or the exponent. Please, do you understand that? Base and then power, right? Or exponent or index. Now, when it's several, that's what we say what? Indices, all right? So the laws are basically two. Let's take a look at them. All right, so law 1. I want you to know that before we can even move into the multiplication. All right, so law 1 of indices states that when you have a number, say A, with a power, multiplying the same number, all right, with probably the same power or a different one, what matters to us is that the base, the numbers, the bases, all right, are the same. Per the rules of, or the laws of indices, it says that just write one of the bases since they are the same, and then the power, you add them. I really want students to understand how I explain it much more than what I write here. Okay, so for example, 2 exponent 3 multiplying 2 exponent 3. So if you remember very well, I said that when you have a number with a power, multiplying the same number, right, with the power being the same or different, what matters to us is what? The base being the same. What did I say? Pick one of the base, and then what? Because they are multiplying, you add the powers. So you're going to be 3 plus 3. I deliberately brought 3 for it to look alike. Either or me, good. So over here, 2 and then 3 plus 3 is going to give us what? 6. So that is the answer. Okay, so how we understood this, now we can make this same example. 2 exponent 3 multiplying 2 exponent 5. So per the rule of indices or law, all right, what is it saying? So we have 2 being the same, the base being the same, so, and they are multiplying 2. So you add the powers, and you're going to get 2 exponent 8. Good. So that's law 1 of indices. Good. Let's go to division. Okay, pay attention. So it also says that when you have a number, all right, with a power, this time around dividing the same number with a power. The power can be the same or a different number. What matters to us is the bases being the same, and then what they are dividing. The law says pick the common base they are sharing, which is A, and then since they are dividing, subtract the powers. And so with this, we can easily work it on this example. That's even I give you 5 exponents 4 dividing 5 exponent 2. Because the bases are the same, what do? You pick the common base they are sharing, and then you subtract the powers. 4 minus what? 2, making what? 5 exponent 2. Let's try one more. I would try using negative values. So we have 7 exponent negative 3 dividing 7 exponent 9. Okay, so what matters to us is that the bases are the same, so you pick one, and because they are dividing, you subtract the powers. Minus 3 minus 9, subtract the powers. The powers are negative 3 and then what? 9. There's a subtraction sign, obeying the law. Alright, so you're going to get 7 exponent 12. Not a mere 12, but what? Negative 12. Why? You have a depth of 3. You have another depth of 9. No one is going to pay the other. You have a depth of 3. You have a depth of 9. You have a depth of 12. Negative implies what? Depth. Okay, so I said with multiplication and division, you group numbers with the same letters. Alright, and then you apply the laws or rules of indices in solving. Okay, I might say that let's start with multiplication. You can meet it this way. Instead of a exponent m times this, you can meet it a exponent m with a bracket. Alright, then the a exponent n falls inside. It becomes difficult to identify either. So I wanted to do this for you to see. So bracket also means multiplication, alright. So a exponent m with bracket, in bracket a exponent n is the same as this one. Either, and so treat it as this. So you just pick a common base and then you add the powers. Division, a exponent m divided by this can also be seen in a different way. This, the over sign. When you meet a thing like this, you treat it as a exponent m with the ideal division sign, alright? So in this case, once you check the base, they are the same. You pick one and then you subtract the powers. Alright. So having been exposed to these, we can start solving questions. Okay. Alright, I want to wrap that. Alright, so the first part. Simplify, that's the main question. Simplify the following expressions. The following expressions. So with A, you have 4m multiplying 7m exponent 3. B, you have 12xy times 2by times 2c. You have 3xy squared times 5 x exponent 4y exponent 3. Let me add one more before we start solving. You have 16 a exponent 3 b2 divided by 2ab. Alright, can we try this together? So solution. So over here, like I said, you group the numbers and the letters, alright, with the same letters at one side, and then you apply the laws of indices. And with this very one, you can see they are already grouped. The number with the corresponding letter, the letters are the same, isn't it? So it's easy for us to solve. So you multiply the numbers, all right? 7 times 4 is what? 28. And then with the letters, that's when you apply the rules of indices. So it's, of course, you can see they are the same. So m, and they are multiplying. So you add the powers. The power here is 1. So 1 plus the power here is what? 3. So that's what? M exponent 4. Again, you multiply the number and the numbers involved, and then when you are done with the variables, you make sure once they are the same at bases, you apply the rules or laws of what? Indices. Okay. All right. So B. So over here, what do we do? So again, you multiply the numbers. 12 to 24, right? 24 times 2, what are you getting? Is 8, 48, isn't it? So with the numbers, I'm getting 48. Then back at the letters. So over here, what happens? So we have C here. Is there any C anywhere? No. So C, you come. We have B. B is not anywhere, so B is coming, and then C doesn't have a corresponding letter. All right, so it doesn't have any match. So B will be repeated, C will be repeated, and then what? X will be repeated, and then Y is having a corresponding member, and of course they are multiplying. So Y, the power here is 1, and then the power at the other side is also what? 1. So 1 plus 1, making 1 Y 2. Again, you multiply the numbers. B doesn't have any match, so it's there. C doesn't have any match, so it's there. And then X doesn't have any match, so it's there. Y do have a match, so Y, and then the power is 1, 1, so you add them. Now, the main reason why I was writing C and cleaning, if you followed my first lecture, I said in algebra, we like putting the numbers in alphabetical order. Right there. And that's the reason for doing this. Awesome. Let's come to the C part. If you have any question, you can leave in the comment section. I'll respond to them all. Alright, so over here, as usual, you do justice to the numbers. So 5 times 3 is what? 15. Okay. Now, X does have a match, alright? So X, you see here, the power is 1. And the other side, the power is 4. So 1 plus 4. Making X exponent what? 5. And then you come to the Y. Y, you have 1 being 2, and then the other being 3. And I believe you know why I'm adding. They are multiplying. They are the same. So you pick one, and then you add the powers. So that's going to be Y exponent what? 5. Okay. Lastly, D. Over here, they are not multiplying, but they are dividing. So 2 into 16 is what? 8. 16 divided by 2 is 8. You can check from your calculator since you are allowed to use that even in the examination hall. Okay, so the variables, you have A. Now, they are dividing. A has a match here, so you pick one, and then because they are dividing, you subtract the powers. So you're going to have 3 minus, you see, 3 minus 1. And you're going to have A exponent 2. Do you get it? So 2 here, and then the B, there is a power here, so B 2 minus, because they are dividing, 2 minus what? 1 I here. So what are you getting? That's B exponent 1 or B. Anything with a power of 1, we usually don't prefer writing. Okay. There are more. Okay, so that's a D, right? So let's check E out. E, we have 15 y exponent 3 divided by 3y exponent what? 2. Okay, so well, let me finish writing all. So the f, we have 2s t exponent 3 times 4 s exponent 4 t exponent what? 2. And the last one, g, minus 12 m3 n2 all over 3mn. Okay, so over here, they are dividing with the first one, e. So you work the numbers out. So 15 divided by 3 is what? 5. 3 into 15 is 5. Okay, so 5. Then the variables you can see is the same. So you have y exponent 3 dividing another y exponent 2. So per the rules of indices, you pick one and then you subtract the powers. You end up getting y exponent 1. And I just said that anything with a power of 1, you can choose not to write it. Alright, let's move on with f. So you work the numbers out, they are multiplying. So 4 2 is what? 8. Please, at this point, you can pause your video and do them yourself before you wait for my solution. So it's going to be s what? 8 s, then you see there is an s here, so now this has a power of 1. And because they are multiplying, you would have to add to the other power, which is what? 4. And it becomes s exponent what? 5. Then back at the t, 1 has a power of 3, so you add it up to the other, which is 2. And it's also t exponent what? 5. I mean, it's very easy, you know. Can you try the g? The g. So with the g, that is what I said previously. If you listen to me, you see, instead of using the division symbol, we use the other form. All right. So you treat it as such. 12, negative 12 divided by 3 is what? So 3 will go into 12 how many times? 3, 4, 12. But because there is a negative, you make sure put it in front. So it's going to be negative 4. Then m up there has a power of 3. But because they are dividing, you subtract the power. So you're going to have m exponent 3 minus, at the base or the denominator, the power is 1 for m. So that's 3 minus 1. You would have m exponent what? 2. So here is going to be 2. And then n has a power of 2 up there. All right. So because they are dividing, you subtract the powers. 2 minus 1. And the power at the denominator is 1. And of course, you have n exponent 1. And I just said it. You don't write it. All right. Okay. Well, with the examples I inscribed in my notes to use for the lecture is finished. So, but with these very ones, I strongly believe you should be able to solve any question and multiplication and what? Division. Students, I will leave some questions on my page, all right? My Facebook page. It's the same Learning with Ike. Okay, so you can go there and try them. You can leave your answers there. I would, provide the right solutions as time goes on. All right. So we're doing removing bracket. It's still under multiplication. All right. Removing bracket. I would like to rub this. Removing bracket. removing bracket. Okay. Brackets are usually used to group terms together, all right? And an expression having a bracket can be replaced with an equivalent expression without a bracket. How do we normally do that? So we usually use the distributive law, all right? Distributive law. Either with the distributive law, you use the number outside the bracket to multiply each term inside the bracket. All right. Let's take a look at the following examples and how we're going to solve. Okay. So A into bracket B minus C plus D into bracket D minus C. B 2x into bracket x minus 1 plus 3y into bracket x minus 1. C 7 into bracket 3x minus 4y minus 2. Well, let me hold on to these ones. All right. So again, I said, you see, we use a bracket to separate terms, okay? And this can be replaced with a similar expression which basically do not change the question, all right? But I mean, the new expression would be presented without a bracket. And I said we normally do this using the distributive law. So we are come to learn how to use the distributive law. Either. Now, before I start, I want to teach you the rules of integers, as is very important for this study. All right. So rules of integers. Have you heard of integers before? Yes. Maybe in junior high school or even within this very lecture. Sorry, in our previous lecture. You might have heard me using that, okay? What are integers? Integers are negative and positive whole numbers. Negative and positive whole numbers, okay? So if I write 1 is an integer. If I write 20 is an integer. And of course, if I write negative 45 is what? An integer, all right? Because I say integers are negative and positive whole numbers. Let me add that any number standing on its own, all right, without a sign in front is actually a positive number. And so the one here standing alone is positive 1. We usually do not like putting positives in front of numbers, all right, unless perhaps it's found inside an expression. Okay, good. Inside an expression. So 20 is a positive number, right? Good. Now, there are rules governing the usage of integers. Either here you can find it. Okay, so negative times negative. Okay, when a negative number multiplies a negative number, the answer should be a positive answer. It's one of the rules. When a negative number multiplies a positive number, negative values are known to be dominant, and so it's going to be negative. Likewise, when positive multiply negative values, negatives are dominant, and so it's negative. Now, when a positive number multiplies a positive number, it's positive. These are the 4 main rules under integers you must know. Okay, so I'm going to use that here. So the distributive law, that is how we remove bracket. So you take the number outside the bracket, you make sure it multiplies each term inside, all right? So A multiplying B, okay, is going to be AB. Do you understand that? A multiplying B will be AB. Of course, they are positive, so AB, all right? Positive, positive, so you should get a positive answer. A multiplying negative C. A should multiply each term inside, all right? So the next one is what? A times minus C. Of course, it should be AC, but do you remember the rules? Positive multiplying negative, you should get to a negative. Positive multiplying negative value should give you negative. So what? So minus AC. Okay. Of course, A times B is what? AB. A times minus C is what? Minus AC. You are going to do the same thing for the rest of it. Now, plus D multiplying, so you have positive D times B. And of course, you're going to get what? DB. It should be positive, by the way. So plus what? DB. Okay. And then lastly, you have D multiplying positive D multiplying negative C. So you see, of course you should get DC, but then positive multiplying negative should be negative. Is it there? Yes. So minus DC. Then at this point, you apply the knowledge you just had under addition and subtraction of what? Algebraic expressions. What would you have done to this? You will group what? Like terms, okay? And then you solve where need be. But with this, no term is categorized as like ones. A, B. There is nothing like A, B. Alright? There are no like terms. So this becomes our final answer. You can take your time and see if you see something as like one. Well, this bears C, but you know, A in front, it is a D, so they are not like terms. Okay, so let's move to the B part. I'm rubbing that off. If you don't understand, play back. So, over here, you having 2, so watch closely, 2x times x. Of course, per what we did previously, 2 will multiply 1 in front, you're going to get what? 2, and then the x times x, the base are the same. So mind you, it's bears a power of 1. So I add them since they are multiplying, so it's going to be 2x squared. And then you have 2x multiplying minus 1. Alright. 2, the numbers will multiply themselves. 2 times negative 1 is going to be negative 2. Of course, positive 2 plus times negative. Alright. So it's negative. And then x doesn't have any match. So you just write it down. So minus what? 2x. And then you go to the next section of it. You have plus 3y multiplying x. So of course, positive will give positive, alright? So 3 multiplying the number in front will be 3. The number in front is 1. Then focusing on the variables, x times y will be xy. Either positive is what? Positive. So plus 1, 3xy. And then the last part, you have 3y as positive anyways. I said it should multiply each term. So times negative 1. Positive times negative, alright. What is that? It should be negative. So 3 times 1 is what? 3. And y doesn't have any match, so minus what? 3y. Then if there are like terms, you group them. But of course, none of the terms are like one. So that is the answer. You can play the video many times as you want. Good. Let's come to the C. Okay. So over here, the number outside multiplies each term. 7, 3, 21. Then you attach the x. 7 times negative 4. 7 for 28. Alright, negative is there. Positive times negative is obvious. I said all the time negative is dominant. So negative 28, negative 28. Then you attach the y. Then 7 times minus will be what? Minus 14. Okay, none of the terms are like one, so that is it. Okay, you can leave your comment in the comment section for my perusal. Alright, next one. Let me write them here. With these ones, I'll be glad if you try them yourself. So we have, what's that? D. So we have minus into bracket 15m plus n minus m plus n. We have e. With the e, we have 2 into bracket 4 minus 3x plus 2 into bracket x plus y. Then f, you have 2a with a big bracket a plus 3d, okay, plus 4 into bracket 2a minus b, then you close a big bracket. Well, this is my last example for this section. Can you try these together? Well, please try them yourself before you review my solution. Okay, so with this one, what is outside the bracket is negative. Negative 1, okay? So you're having negative 1 times 15m. The negative 1 times 15 will be negative 15. Okay, negative multiplying a positive number, negative is always dominant. So 15 what? M. That's the first answer. Well, D, right? So that's negative 15m. Then you have negative 1 again multiplying positive n. You're going to get what? Negative 1, all right, negative 1n. Do you understand that? Negative is always dominant, so you're going to get negative 1n or negative n. I just told you that when 1 is in front of a number, a variable, we usually do not write. So of course here too you have negative 1 in front multiplying m. That will be negative 1m or m. Alright, and then negative 1 multiplying positive n will be what? Negative 1n or n. Alright, then over here you group like terms there are, so you're going to get minus 15 minus what? 15m grouped with m, but what is in front? Minus m. Alright, then you start pairing the n's. Minus n. This is going to give us minus 16m minus n plus n, negative n minus n, alright? There is 1 in front. 1 is in front. So you are owing 1, you owing another 1 again. You have a depth of 2. That's a minus you see. And yeah, if you're wondering how I had a 16, there is 1 in front. You owing 15, you owing 6, or you owing 1. Alright, so you are now owing 16. Alright, and that is it. Okay, next one. E. 2 multiplying 4 is what? 8. Minus 2 times negative 3x. That's going to be negative 6x. Then here you're going to have 2 times x, that's what 2x, then plus 2y. You should do them yourself. So if you solve this, you would, well, let's group like terms first. So you're going to have minus 6x pairing with what? 2x. Then now 2y can come. The 8 is obvious, it's positive, so it can come. And so when you're carrying a number, carry it with a sign, and the sign in front is positive. So here you should have negative what? 4. Then you attach the variable. It's negative because you owe 6 and you have an amount of 2. 2 will pay some of the 6. In fact, 2 out of the 6, you'll be left with 4, which is a debt. So plus 2y plus what? 8. Okay. Any questions so far? Alright, we can now look at the last one. Can you please try this before I produce the master solution? Can you try this yourself? Okay, so over here, I would advise you deal with everything in a bracket. When you are done, then you come and use the number outside. So 2a should still stand there, and then you open the big bracket. Now over here you have a plus 3d. If you could have been added, I wouldn't have wasted so much time. But they cannot be added. They are not like terms. So let's work on the other side, which seem, which there's more work to do. Now, actually you have positive 4 times 2a. You would get 8a. Positive. Why? Positive multiplying positive is positive. Then you have positive 4 multiplying negative b. Well, the number in front is 1. So positive 4 times negative 1 is negative 4. I just said positive 1 is meeting a negative value. It's negative. Okay, then you attach the variable. So that's our minus 4b. Okay, you can now close it. That's the first part of it anyways. Now you group like terms. So over here, you're having a matching with what? 8a. Then 3d and 4b doesn't have a pair. So still 2a. Now solving this will give you 9a because there is a 1 in front we usually do not write. So 9a plus 3d minus what? 4b. Now this appears just like what we've been doing so far. This. So you just use what the contents outside to multiply everything inside. Okay. Let's start with 2a. 2a multiplying 9a. You're good at this, isn't it? 9 to 18. Then a, because they are similar and they are multiplying, add the powers. It's going to be 1 plus 1. That's 18a squared. The next one, 2a multiplying 3d. You should get 6ad. Alright? 2 times 3, 6ad. Either will mean, because they are not the same. And then minus 2a multiplying 4b will be what? 8ab. Good. They are not like them, so this is your final answer. With this very example solved, you should be able to solve any question under removing brackets. Okay. So then this brings us to the end of this, the third lesson. Okay. Yeah. Now, fourth lesson, I'll teach you how to multiply two binomials. So meaning we're still under what? Multiplication and what? Division of algebraic expression. And then when I'm done, we'll start dealing with factorization. If you have not subscribed to my channel, please do so. Tap on the bell so you get a prompt anytime I make an upload in your absence. See you in our next lecture.